This is IB Math AAHL week 9, 8 to 9, something like that. In the past couple weeks, we've gone over functions, function transformations, inverse functions, composition of functions, and of course quadratics. So we'll start with functions and go through each subset of them and end with quadratics. Functions. This is a fun topic. So unfortunately functions are pretty big, but most of the functions like standard form, vertex form, x-intercept form, finding the domain and range for that is something that is usually learned earlier on. Um, so I'm gonna skip over that, and I'm gonna do what IB's favorite, at least what seems to be its favorite kind of function is when y equals a fraction. That's the one that I think my class has done the most of. So we'll probably see the most of that on the test. So let's take y equals 2x minus 1 over 1 minus 3x. And usually for functions you'll have to find the domain, range, asymptotes, and you'll have to graph it. So let's start off with the domain, which is usually the easiest. And in this case it's very easy. I forgot how to spell domain there for a second. We just have to look at the denominator and see what x can't be. So we know that you can't divide by 0, so we just want to find when this equals 0. And I mean, I guess we can use algebra to solve this. You're gonna end up getting that x equals 1/3. So that means that in the function x cannot equal 1/3 because then it'll be 0. So the domain, it can be written, I think the easiest way to write this is it can be all real numbers minus this 1/3. And since it can't be 1/3, it means that the vertical asymptote of this problem is going to be 1/3. Okay, so that's the domain. Now the range is a bit trickier, and it usually is. We need to find the values what y can be. So if we just write the equation again, first thing I'd recommend doing is always get rid of the denominator. It makes things hard. So yeah, the best, just get rid of the denominator, and how we're going to do that is multiply on both sides. So we'll have y times 1 minus 3x equals 2x minus 1. And now we want to expand out the left side, so we're going to have y minus 3xy equals 2x minus 1. Third step, get all the x's to one side. So what we're going to have here, if you just move around the numbers, you're going to have negative 3xy minus 2x equals negative 1 minus y. And negative 1 minus y, you can also just write that as, oh, sorry, no, I'm getting ahead of myself. Then you want to take away the x. Well, not take away, but factor out the x. And it'll be negative x times 3y plus 2 equals negative 1 minus y. And if we just multiply negatives on both sides, it will be x 3y 2 equals 1 plus y. Okay, we're almost done. Now we want to get x equal to something. And you know, I think it's pretty clear what you should do here. You just divide the 3y plus 2 on both sides. So you're gonna have x equals 1 plus y over 3y plus 2. And just like how we found the domain before, we're gonna say what 3y plus 2, we're gonna find what it can't equal. It can't equal 0, which means that y cannot equal 2 over 3. So the domain of, I mean the range of the function is all real numbers minus 2 over 3. Sorry, I wrote that kind of weird, but yeah, that's the range. That's the range of it. And since now we have the domain, the range, this is also the horizontal asymptote. So you can say the asymptotes um, are, you put x first, yeah. So 1/3, 2/3. Those are your two asymptotes. And now, the hardest part I'd say, which is graphing this function. Hopefully for harder functions, you're gonna have um, a calculator to use, but sometimes you won't. I think this one you probably would. But we're gonna write the function again, not rewrite it. Go back to what it originally was. And I think for this one, you'll probably just have a graphing calculator uh, so you can just draw it pretty easily. Um, but yeah, I mean, I think they would give you one. If you put it in a graphing calculator, it'll come out to be like this. This is one of the things where it's just kind of hard to. It would be a pain to draw it without the calculator, and it would take up way too much time. So this one they'd give you something to use. And I didn't draw it super well, but this, let's say these lines, they touch, I guess. This is gonna be one right there, that point right there. So yeah, that's a rough drawing of that function. It's not amazing, but yeah, that's what it's gonna look like. I will actually do another example of a function because I think it's important to know how to do functions that have why is my thing not working? Functions that have square roots involved with them. So let's say we have y equals 2 minus root x, 2x actually, plus 3. Sorry, this is not written too well. Y equals 2 minus 2 minus square root 2x plus 3. So to find the domain, well, um, nothing inside a square root can be negative. It can only be 0 or greater. So what we're gonna say is that the square root of 2x plus 3 is greater than or equal to 0, which means that 2x plus 3 is also greater than or equal to 0. Because if it's 0, then the square root of 0 is 0. So now, given this, we're just gonna I'm gonna quickly also I'm gonna go quickly through this so I don't waste too much time, but just switch the numbers around and you're good to get that x is greater than or equal to negative 3/2. Yeah, so then you write it like this. Oh, sorry, not the range, the domain. Okay, that's the domain. Range, since we just stated that the square root of 2x plus 3 has to be greater than or equal to 0, right? It's a 2 minus the square root of 2x plus 3. And so we want, I mean, the greatest value that y can be in this case is 2, because if this number is greater than 0, then it's going to be a smaller number. So the greatest we can have is 2 minus 0, which equals 0. So that means that's the greatest value for y. So, I mean, that's what we're going to write, since that's the greatest value for y. Y is less than or equal to 2, and that's the range. Um, Range is all real numbers um, less than or equal to 2. Okay, now for graphing this, I'm going to erase all this. Y equals 2 root, not 3, 2x plus 3. So for graphing this, as we just found the asymptotes to be negative 3 over 2 and 2, we're going to take our graph, and for a problem like this, they're not going to ask you for the specific points. It's just like a rough sketch of the graph. And so our x is going to be back here. We're going to have a coordinate 3, 2. So because this would be negative and this would be positive 2. Um, and we know that x was greater than or equal to negative 3 halves and y was less than or equal to 2. So we know that has to go downwards. Yes. Uh, let's draw the point up there. We know that has to go downwards, and I drew that really, really bad, sorry. I was trying to draw a dot. That's the dot right there. And so the graph, you should know that graphs of square root, like let's say this is y equals root x, they go something like this. They go like that. So this graph is going to be the same thing, just with this starting point a little different. But it's going to be the same thing since it's just a square root. It's going to go like that. Sorry for the cutoff. I had just finished drawing a graph and I realized the graph wasn't off, but it wasn't entirely accurate. Or it was misleading. Let me just draw this out to make it more clear. The graph, it'll follow like the square root pattern, like the over here. It'll follow the same pattern. It'll go like this. It'll go something like that. So this is a graph that you can probably do without a calculator. Composition of functions. I don't think this will take as long as the other things, but let's say that if you have f of x equals 2x squared minus 1 and g of x equals x plus 1. Well, if you wanted to say what is f of g of x, the g is going to be what you plug into the value of x in the f of x. So you're going to end up having 2x plus 1 squared minus 1. And if it was the other way around, g of f of x, you just do the same thing. The f of x becomes the value of x in the g of x. So you'll have 2x squared minus 1 plus 1, which equals 2x squared. And if x is any number, then you just plug in whatever that number is to the final not value, to the final function that you have when you combine the two functions. So you also need to know how to work with graphs. Usually in graphs they won't give you the dotted lines drawn out like this, and you have to find where the points meet, but for the sake of time I already drew them out. So let's say you have f of g and x is 0, which is the same thing as saying f of g of 0, what you need to do is you find, so you start with the g of x graph, the one on the right, and you look at where x is 0. And when x is 0, the g axis is also 0. So then you take that and go on to the f graph, and you find when the x is, or sorry, yeah, no, when the x is 0, then what is the f? In this case, it's 1, because the graph starts at 1. Um, so that is 1. I think this will be an easier way of showing it if you have f of g of 3 equals f of, this equals f of g of 3. And so, for this one, you find where the 3 and the 5, where the 3 meets, and that meets the 5 at this point. It's not drawn perfectly, but it meets the g at a value of 5. So you take that g equals 5, and you go to the, you put that in for the x-axis of the f of x graph. That that value of g becomes the starting point for finding the value of f. So you take this 5, and g equals 5, and you look at where the x value of 5 meets the f value on the other graph. And you can see that it meets at this point 5 and 4. So then you're going to have that f of g of 3 equals 4. It's not super, I don't think that was super clearly explained. I'll try another example. Hopefully uh, you'll get it after this one, but let's say the f of g, you have f of g of 4. So you look at what value of x meets g on the g of x graph. That's what you look at first. And you can see that it's 2. When x is 4, it meets g at 2. So you take that g value, which is 2, and you use it as the x value for the f of x graph. And you find where 2 meets the f value, and you can see it meets at value 3. So then you're going to have the f is 3, so you're going to have f of g of 4 equals 3. Okay, quadratics. I would say quadratics are the topic that we're probably most familiar with because of past years, but you know, IB seems to go a bit further into them. So you're gonna need to know, of course, the basics, like how to get the vertex, y-intercept, x-intercepts. Graphing is a little bit harder with the new quadratics. You're gonna need to know how to obtain a quadratic from another one, with stretches and translations. Uh, you also need to know how to expand quadratics. I'll try to go over everything that we need to know. So here's the first problem, and this is only the first part. I'm gonna write out the entire solution first, and then go over it so we can get past the somewhat easier stuff and get on to the harder parts of the problem. But, so for the first part of this, it says, let f of x equal 2 times x minus 1 squared minus 8 for x equals all real numbers. And part A wants us to show that f of x equals 2x squared minus 4x minus 6. And how we do that is we just expand the what the f of x is. As you can see, I rewrote the equation here, which will turn into 2x squared minus 1 times x squared minus 1 minus 8 because of the squared that we had over here. And this will change into 2x squared, 2 times x squared minus 2x plus 1 minus 8. Multiply everything by 2 in the parentheses, and you're almost done. You just have the plus 2 minus 8, which will of course be minus 6. So you have 2x squared minus 4, minus 4x minus 6. Now we want to find the vertex y-intercept and x-intercepts. For the vertex, there's two ways to do it. You can use the x equals negative b over 2a, and you'll get that x is equal to 1. For the negative b over 2a, you want to use this equation. Um, and then you plug in x equals 1 to either one of the equations to get y equals negative 8. Or you could use what I think is the easier way. You just look at what the vertex form, which is over here, and you see that h is 1 and k is negative 8. So either way, you're going to get x is equal to 1 and y is equal to negative 8. That's the vertex. For the y-intercept down here, you just, for either equation, you plug in x is equal to 0. And as you can see, you um, 2 times 0 is 0, 4 times 0 is 0, so you just have negative 6, so y equals negative 6. For the x-intercepts, it's a little bit more tricky, but you take out the 2, as like you can see I factorized, and then you have x squared minus 2x minus 3. And then you're going to want to factorize that out to get x plus 1, x minus 3. And so then, since it's x plus 1, x is going to be, you want to find where you get this to 0 and this to 0. So x is going to be equal to negative 1, and x will be equal to 3. So x is equal to negative 1 and 3. Okay, now that we've gotten the easier part out of the way, we can do what I think is harder. Here we have the f of x equation, the standard one we had before, and we have a g of x equation. G of x equals 6x squared for x equals all real numbers. And it says that graph f of x may be obtained from graph g of x with the transformations, a compression of the factor a in the y direction, and translation of h and k. So how you do this is, I would start by writing out the transformations. So for the first one, a compression of a in the y direction, what this is saying is that the f of x will be equal to, if we're just going to disregard the translation. So we take this a, I'm going to have a times g of x, whatever g of x, well, it's 6 times x squared, but we don't need to worry about that right now. So we get the a, and we just multiply it by the the g of x equation. Now for the translation, we have f of x equals, and what we're gonna do is we're gonna have g x minus, as you know, the vertex form, the h is minus because it's inside the parentheses, minus uh, h plus k, and this is obtained from here, there. So for the h, you always do minus. Unless it's a negative number, then it's negative times negative, it's plus. But for the k, it's whatever the value is. If it's negative 5, you do minus 5. If it's plus 5, you do plus 5. And so now if we just kind of combine these two equations, we'll have that the f of x is equal to a g of x, g of x minus h plus k. This is the full equation that we have from these transformations, and we're going to find numerically what f of x is. So to solve this equation, um, what we're going to do is we have the f of x equation, and we're going to say that this equals the ag times x minus h plus k equation that we have right here. And how we do this is, well, we're going to have a on the outside, and we'll have some brackets, and then we have the g of x equation. How we plug that in is we have 6 and x squared, but if you remember the x, we're subtracting h from it, so we're gonna have h minus x minus h squared brackets, and then of course plus k. And all we need to do, it's actually not too hard. Let's just say this is 6a x minus h squared plus k. We're gonna want to get this 2 and this 6a to equal each other. We want this to equal each other. We also want to get this x minus 1 and x minus k to equal each other. Um, I didn't write that correctly, sorry. X minus 1 equals x minus k. And of course, we would just want the k's to equal each other. So we're going to have negative 8 equals k. So for this one, 2 equals 6a. A will be equal to 1/3. For this one, x minus 1 equals x minus k. X minus h. H will be equal to 1. And for this one, we already have it. Negative 8 equals k. So we just found what the a, h, and k values were when you have the equation f of x equals a g times x minus h plus k. I wanted to do this problem because I think it's a bit tricky. So we have f of x equals log base k times 8x minus 2x squared, and x is greater than 0 but less than 4, and k is greater than 0. So we're given that f of x equals 3, and that we have to find k for when f of x is 3, and we're given also that there's only one value for k, which is it's going to be important later on. So first we set 3 equal to the equation log base k, and so on. And if you remember the how to change a logarithm into a standard indice equation, it's log base a times b equals c, changes it to a to the power of c equals b. So with this information, we're going to get k to the 3 equals 8x minus 2x squared. And the 3 is just gained from that 3 right there. And so this will change into, if we subtract 8x minus 2x squared on both sides, we're going to have 0 equals k to the third. Um, and I guess we can write this a bit different. We'll say 2x squared minus 8x. And let's just rewrite this as 2x squared minus 8x plus k to the third. I think it's a bit easier to see it that way. And all we have to do from here is use the discriminant formula to find k. And in case you don't remember, discriminant is delta equals b squared minus 4 ac. In this case, c is our k value. And so we're going to end up with negative 8 squared minus 4 times 2 times k to the k cubed. And as I said before, there's only one value for k. We're told that in the problem. So if you remember the discriminant, if there's only one solution, then it's equal to 0. The discriminant, the delta equation, is equal to 0 if there's one solution. And so from here, we get 64 minus 8 k to the power 3. And then this will change into 8 minus k to the power of 3 equals 0. And sorry, this also equals 0. Should have made that clear. And this is we get this just by dividing 8 on both sides. And so now that we have 8 minus k cubed equals 0, then we have 8 equals k to the 3, so k is equal to 2.